Have is two sets A and B, and we're going to represent them with a Venn diagram. So we get our two ovals as shown, 1 and 2, call them A and B respectively. Now, what do they have in common? I always start off in the middle. What do we have? We have 4 and 5, 4 and 5. We also have 6, we also have 6. So 4, 5, and 6 off the list. So 4, 5, and 6. Okay, then in A only we have 1, 2, and 3, and in B only we have 7 and 8. Now we're going to list the elements of A less B. Now, A less B means everything in A that's not in B. So everything in A that's not in B would be this region here. See the way you're not allowed to go in the middle because those 4, 5, and 6 are also in B. So the answer is 1, 2, and 3. Okay. And then finally for part B, we have B less A. And what's B less A equal to? Everything in B that's not in A. Well, we can say that's 7 and 8. 7 and 8 are in B only, but 4, 5, and 6 are also in A, but you're not allowed inside of A, so 7 and 8. Okay, now on to question 2. Well, it's meant to be 2. There we go. P and Q. So once again, we're going to get two ovals to represent P and Q. And then we're also going to get a rectangle. Oh, sorry, no need for the rectangle, my bad. Rectangle's not needed. So P and Q, once again, start in the middle. What did they have in common? A and C. A and C. Anything else? No. So A and C goes in the middle. And what's left over in P is B and D. And what's left over in Q is E, F, G. Okay. List the elements of P less Q. Everything in P that's not in Q. So P less Q is B and D. They're the only things that are in P but aren't in Q. So what's a B and D? My fault. B and D. Now, part B. Everything in Q that's not in P. Q less P. Everything Q that's not in P is E, F, G, because A and C would be in P, so you're only allowed E, F, and G. E, F, and G. And you're done. Now, evaluate the cardinal number of Q less P. How many numbers are there in Q less P? Well, there's 3. Take away the numbers in P less Q, which is 2. 3 take away 2 equals 1. And that's part 3 done as well. Okay, now we're on to question 3. Alright, I tend to draw out the diagrams even when it doesn't ask me to do them, because I'm a visual learner, so I need to do this using diagrams. It's the only way I'm going to get the correct answer. So what do we have here? We got to do X and Y. So call this one X, call this one Y. What did they have in common? They have P and Q. P and Q. This one is R and S. And this one is U, V, W. U, V, and W. Okay, part 1. X less Y. X less Y is everything in X that's not in Y, which is simply R and S. Has to be inside X, but is not allowed to be inside of Y. Part 2. Y less X equals everything in Y that's not allowed inside of X, which is going to be U, V, and W. Okay, next question. Everything in X that's not allowed in Y, or everything in Y that's not allowed in X. Well, very simply, this is everything in X that's not allowed in Y. This is everything in Y that's not allowed in X. And if you do both answers combined, it's going to be R, S, U, V, W. Okay, R, S, U, V, W. 1 second. There it is there. This answer for part 3 equals R, S, U, V, and W. It's basically this answer combined with this answer. Now, everything that's in X, everything that's X but not allowed inside of Y, and everything in Y that's not allowed inside of X, has to be both of them at the same time. There has to be an intersection here. Okay, let's find out. Is there an intersection between RS and UVW? And the answer is no, there is no intersection. They have no numbers and no letters in common. So this answer is going to be the null set. Okay, so they have nothing in common. Part 4, on the current page. So we have to write down the null set for part 4. Oh, where did we put it? There we go. Equals the null set. Okay, now on to question 4. Now, from the Venn diagram shown, say true or false to each of the following answers. Everything in the universal set is 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is true. Oh. Or I can just write true over here. Okay. P intersection Q is 3 and 4. False. It's 3, 4, and 5. Everything Q that's not in P is 9 and 10. Nope, it's 7, 9, and 10 are all the numbers inside of Q but aren't inside of P. So that's false. 7, 9, and 10. The amount of objects in P, everything in P that's not in Q amounts to 2 objects. Well, it's 1 and 6, which is 2 objects, so true. That's everything in P that's not in Q is 2 objects. That is true. Okay, next one. Everything in, we'll use a highlighter for this one. Everything in P union Q, P union Q is all of this yellow region, but you're not allowed B inside of P intersection Q, so you're not allowed B to 3, 4, and 5. So how many do we have there? 1, 6, 7, 9, 7, 9, 10. 1, 6, 7, 9, and 10. That is true. Okay, question 5. Now with question 5, guys, I'm going to have to draw a diagram here because I won't be able to do that without drawing a diagram. So let's draw a diagram. Venn diagram. Here's 1. Oop, sorry to go again. There's 1. There's 2. And finally there's 3. Okay. Then you have A, B, and C. Now what, start off dead center. What do they have in common? What do all 3 of them have in common? I see 2 here, 2 here, and 2 here. So that's the 2's gone. 2 is dead center. Okay, let's concentrate on A and B. What do A and B have in common? Well, they have 1 in common, so that's in between A and B. Anything else A and B have in common? Nothing. What do A and C have in common? I see a 5 in A and C, so I'll put a 5 here. Anything else A and C have in common? Not much. What do B and C have in common? Well, just the number 7 by the looks of it. So that leaves 6 inside of B, 3 and 4 inside of A only, and then finally what do we have inside of C only is 9. Okay, so let's get working on a few of these questions. Answers are made. Okay, so what's A less B? Everything in A that's not in B. Well, here's everything in A that's not in B, because you're not allowed B in the intersection with B. So it's 3, 4, and 5, because you're not allowed to be inside of B. Okay, part 2. Everything in A that's not in C. So everything in A that's not in C. Well, you're not allowed in this region here because this is C. So everything else that's in A is 1, 3, and 4. So everything in A that's not allowed in C. So that's going to be 1, 3, and 4. Okay. Part 3, B less A. Everything in B that's not inside of A. Well, we have 6 and so you're not allowed to be inside of A. So you're not allowed any of these numbers, but you have to be inside of B. So that means 6 and 7. Okay. Part 4, B less C. Everything in B that's not in C. So you're not allowed inside of C, but you have to be inside of B. So that's just 1 and 6. Okay, A union B, everything inside of A and B. So what do we get? 1, 2, 3, 4, 5, 6, 7. Okay, that's A union B. Now next one, A union B, but you're not allowed inside of C. So A union B is this region here, but then we got to discount the letters that are in C. So we're not allowed 5, 2, and 7. So it's simply 1, 3, 4, and 6. Okay, so it's 1, 3, 4, and 6. So for part 6, it's A union B, less C is 1, 3, 4, and 6. All right, part 7. B intersection C. B intersection C is 2 and 7. Okay, part 8. Everything in A that's not in B intersection C. So everything in A, but you're not allowed in B intersection C. So B intersection C is the red line I'm drawing around. You have to be inside of A, but you're not allowed inside the red circle, which is B intersection C, or the red boundary. So it's just 3 and 4. So everything in A that's not in B intersection C is just 3 and 4. Oh, sorry, B intersection C. Sorry, guys, I got that wrong. Go back again. B intersection C is 2 and 7. It's not union, it's intersection. So B intersection C is 2 and 7. Everything in A that's not in the red boundary is 1, 3, 4, 5. Okay. So that's that one. Part 8, B union C. Or part 9, I mean, B union C. So everything in B and in C will be everything in this region here. 1, 2, 5, 6, 7, 9. Okay. The next one, part 10. B union C and B intersection C. So everything that's in B union C, but not allowed in B intersection C. So get this. B union C would be all these here. This is everything in B or C, but you're not allowed B in B intersection C. And B intersection C is, need a darker color here. Is, oh god, that's not a good mix. B intersection C is these two guys here. The 2 and the 7. So you're not allowed to use 2 and 7. So the answer is 1, 5, 6, and 9. So 1, 5, 6, and 9. So what's that? Question 10. B union C, but not allowed in B intersection C. So once again, what do we say is 1, 5, 6, and 9. Okay. Next question, B intersection C less A. This is part 11. B intersection C, but not in A. Okay. B intersection C is this part here, but you're not allowed inside of A, so that means you're not allowed to 2. So the answer is simply 7. And you're done. Okay guys, that's exercise 10.6, 1, 2, 3, 4, 5, I believe.